Let me share a little bit about the PVT and the closed-base PVT methods, because they are very similar, but also a little bit different. If we look into this image, then this is a schematic of the PVT. And PVT stands for physical vapor transport. So the schematic is a container. On the bottom, you have the silicon carbide powder, which acts as a source. And then you heat this up, and you have different species, silicon, 2 silicon, 1 carbon, 2 carbon, 1 silicon, which are formed. And when you have the seed at a lower temperature than the source, the vapor species are diffusing towards the seed, and the crystal is growing. Physical vapor transport. This is the most common process for the growth of silicon carbide. And it is established since many years, since the research in 1990s and maybe a little bit before. Then it has matured now, so it's an industrial process. In comparison, the closed-base PVT is the same configuration, same type of box, hardware, but the difference is that instead of powder, you have a solid source. Instead of long distance between source and seed, it's much shorter, and then you have a substrate, a source, and you can still use the PVT process not for growing boules to make wafers, but you can grow thick layers using the sublimation principle. This is an image of a CS-PVT layer grown many years ago on a small wafer. And the purpose of that one is to make thick layers. And at that time, there were interesting new projects about fluorescent, meaning light-emitting silicon carbide, growth of cubic silicon carbide, even aluminum nitride on silicon carbide, epitaxial graphene on silicon carbide, using the closed-base PVT concept. The growth is fairly similar. On the left side, we see the typical schematic of the growth of silicon carbide to make wafers. So this is now an industrial process. So let's call it industrial PVT. And on the right side, you see the CS-PVT, closed-base PVT process and schematic. So you grow a layer on a substrate in case of CS-PVT. And for the PVT, you grow a boule on a substrate. But this substrate is called seed in the case of boule growth. But they are doing the same thing, that they are there so the grown material can be reproduced by the polytype. And from machinery point of view, the hardware, you have a PVT hardware. You take your box with PVT concept and you put it in there, and then you have a PVT process. And then you can take the same machine, you have a modified design of the CS-PVT process, you put it in, and then you can grow the material using the same machine. The advantage is that then you can use industrial tools, which are commercially available, to grow CS-PVT material. Now many of the things in CS-PVT are in research, but once those are in research, and if you do this on wafer scale using industrial tools, then you have much shorter gap from the research to the possible markets and new applications using the CS-PVT concepts. This makes it interesting that we can actually combine these when we have the wafers from the PVT process. They are now in such high volume and lower price that we can take them, and then we use the CS-PVT to grow layers and explore new things. And since we use industrial tools, wafer scale, and we have lower cost, then that means that it is actually feasible to have an exploitation of the CS-PVT applications once those have increased in maturity and got higher technology readiness level. This offers new markets, new avenues, even new applications. But first of all, it offers a lot of new research opportunities.